This is the video for truck dynamic programming routine. Here on the left is the beginning of the routine, and over here on the top right is the end of the routine. But this routine calls a subroutine, and here is part of that subroutine that it calls. Well, the dynamic programming routine starts out with set the max load to 20. That's the maximum number of pallets that can be on the truck. Then it starts a loop for I starting at 0. And over here on the right is the end of that loop, next I 2 to 1. It's going to go around this loop for 0, 1, and 2. That's for each one of the 3 cities. The next thing it says is set j to I, multiply that j by 6. That's because for each one of the cities, there's 6 units in front of the city. Each one has a number of pallets, so it's going to move the number of pallets, the 6 of them, to work pallets. It's going to take the 6 load profits and put them into work profit. Then it fills the 6 values in work loops with 0. Now it's going to go around a loop here, and sometimes it's going to set work loops to 1. Let's see what it does. It sets L to J. That's this offset for 6 we have up here. And then it says for K of 0, next K5. Well, that's 6 times it's going to go around from offset 0 to 5. It says branch if not equal, the load city is not equal to I. Well, if it's not this city, it says it goes to AB. In other words, this particular unit's load is not going to the immediately following city. It's going to one of the other cities. So it doesn't want to do the next thing, which is to set the work loop K to 1. This K refers to which unit in front it is, from the 0 to 5. So it's a 1 if it actually is going to the city that immediately follows. Once it has marked all these work loops, it then can go to this subroutine that we have over here on the right. It says here it's going to go to AE and return on the address in W. Well, we don't see AE here because this is actually the center of nested loops. It has a for A, B, C, D, here's E and F. It has a do loop, well, for next loop we'll call it, for every one of the units in front of the city. It's going to go around here 64 times, 2 to the 6th, because it's going to either have that particular unit serviced or not serviced. And it's going to put in a list called profit list. The profit, if it is in that included, and the number of pallets that's used. First, there'll be 0. It won't include that particular service unit. And the next time it goes around the loop, it'll say, yes, I have it included. This is the profit, and this is the number of pallets. So right down here in this area is what it does 64 times. It sums up the number of pallets being used by whether the different units are in the solution or not in the solution. It sums them up and puts the value in S. Well, it needs to check for if it's a valid solution. It doesn't want to save one it isn't, so it says branch if less, S is less than 1, meaning, well, there's no pallets in the solution, I don't want it. It goes down here to AC and doesn't do its work here. Also, if S is greater than the maximum load, which is the 20 pallets, it's not a valid solution either, so go to AC, go down here. Well, if it is a valid solution, well, then we want to sum up the profit from those particular units that it's getting the pallets from, put that in P, If that is less than or equal to the answer profit for that number of pallets we already have, we're going to AC. However, if for S number of pallets this is a better profit, well then we go down here and we set the answer profit for that number of pallets to P, and we set K equal to S, multiply it by 6, because we need 6 times the offset to save that answer of its pallet list in answer data at offset K. So we're saving not only what the profit was, but what units pallets were in that solution. All right, this is part of the subroutine referred to over here. So it's going to be going around this loop 3 times. It's going to do this for each one of the cities. Next, it sets the best profit to the answer profit. That's what it got over here. And moves the 6 values of answer data. Remember, that's when it saved the pallets of answer data to best data. Sets L to 0, and now it's going to go around a loop here. And what it needs to do is have the information that dynamic programming is going to want. And that is, if I come back to this solution and I say I have room for 6 pallets on my truck, I want to know what the best profit is if I have room for 6 pallets. Well, it could be that, well, the best profit is for 5 pallets. Well, if I'm telling it that is, that I have room for 6, I certainly have room for 5. So it could be that the best answer for 6 was 5. So here we have a loop that says, for K of 0 all the way to the maximum load, it's going to say if the previous number of pallets was a better answer, use that one. So it says, branch if less than, the best profit is less than the profit that we're looking at right now. Go to AG and say, well, that's a better one. If not, we just say this particular one is going to get the answer we already have for best profit and best data. So as I say, if that comes back and says, for instance, I could take 8 pallets on my truck, well, the best answer may be you only need to take 7, 6, 5, 4, whatever. All right, that's what this does. So the dynamic programming solution for it that it uses later can just say, I have room for this many, what's my best profit? Well, then it goes over here and it says, set P to I, multiply P by 30, move the 30 values of answer profit. Remember, that's what we've been figuring out down here, to keep profit at offset P. Also set L to I, multiply L by 200, and save all the answer data that you've got. Now, this information is going to be used for when it uses a dynamic programming routine to figure out if I include units that do not go to the following city, they go to a subsequent city, that routine will be able to solve the problem overall. So this really isn't the overall dynamic programming solution to this problem, because this only made tables for when the pallets are delivered to the immediately following city. All right, this is the end of the video for truck dynamic programming routine.